Hello and welcome to this tutorial on SkyCiv Beam. Today we're going to be exploring how to design a timber beam element using the SkyCiv products. Today we're going to be focusing on the Canadian standards, but you can do this also in the same program using NDS standards, Australian standards 1720, and the Eurocode timber design standard as well. So the process is pretty much the same for all of those design codes. We're just going to look at the key parts or the aspects of the design process, but you can pretty much do them all the same with the same design flow. So this is the example we're going to be following. We're just going to try to design something like this. Could be a roof truss element, could be a critical element in a large timber design. But yeah, it's just going to be an indeterminate beam with a mid-span support and some dead loads, live loads, snow loads and wind loads. So we'll start by just loading SkyCiv Beam. So we're just going to start fresh. SkyCiv Beam is really quick and easy to add in all your different elements. So the span is 6 meters. The support, we'll do one at 0, one at 3, and one at 6. And the section, so we're going to run the section builder. We do have the database shapes here, so we can load in from the American, the Australian, European, Canadian. So all the different design standards for steel, aluminium, cold form steel, but for today we're going to be focusing on the timber. So we're going to be loading from the Canadian CWC database. So quite a lot of different material types. We're going to go with the finished structural light framing today. And we're just going to pick a 2x4. And the first thing you'll see is this will pop up for asking you to select a database material or an existing material. Now when we're designing with timber, we want to be very specific about the type of material that we are using. So I'm going to open the database and make sure to select something from my relevant design standard. So here I've got the CSA, and we're going to make sure to also match our section that we've selected. We can see it's finished structural light framing with something similar or of a relevant material. The design module will try to pick up and detect if you've cross-pollinated some of your sections with maybe materials that aren't applicable. But yeah, it's just an important part of the process is just making sure that we're selecting a relevant material. So I can see my different material properties here. I can review them, but I'm happy with that choice. I'll go ahead and submit it. And we can pretty much start adding the distributed loads that we mentioned earlier. So we'll go back to our drawing. We've got a dead load of 0.5 kilonewtons. So just going to tab through here, 0.5. So the dead load could be your roof or your sheeting, any loads that are pretty permanent on the structure. And we'll also add some live loads. So they were 0.25, oops, sorry, 0.25, some snow loads, and finally some wind loads, 0.35. So you can see the different types of loads that have been added here. We've given them different load cases as that's an important step when applying our load combinations. Again, these can be imported from the various design standards. So we've got the Australian standards, US, Europe, Canada. So today we're going to choose the NBCC, which is the Canadian design standard. And we're just going to review the load cases, just making sure that we've categorized them correctly. The software will do this automatically, but there are multiple types of dead load. So if we've just said dead load, we want to be more specific. We might want to choose the correct category that's relevant to the NBCC standards in this case. Snow load is matched up correctly. The roof load is a live load, that's good. Wind load, so they all look good to go. So I'll go ahead and import. And you can add your own different load combinations, but for today I'm happy with the NBCC prescribed standard, load combinations. And so I'll go ahead and save that. And I'm pretty much ready to solve. I'll just toggle on the self weight and run the solve. So here we're presented with some pretty clear and easy results to interpret. So I've got my design report here with all my diagrams clearly defined. I also get a 3D rendering, so I can see it's quite a slender section, which is showing itself in these the rule of thumb results that we've got here on the right. So this is basically tell us what the deflection limit at L250 is, that we're L over 85, which is significantly higher than that limit, so almost 300% utilized. So it just gives you a snapshot in your model and enables you to make quick and easy design decisions. It's not as thorough as the CSA 086 that we will run, but just as a snapshot, it's quite handy. It has run through all the different load combinations that we have, so all the different ULS cases, even the different individual load cases as well. Just make sure we're capturing all the different possibilities of this design. But yeah, I'm going to stick to the envelope max result. That basically tells me the worst case scenario in all my different load combinations. So I can already see this design probably isn't going to pass. If we're failing some of these simple checks, there's clearly something going on, or there's not enough material to support that load. So I can already come back. Maybe I want to modify my design. We can introduce another support. So we'll put in something, say 2 meters. So introducing that other support might give it enough strength to support those different combination of loads. Okay, so now we're much closer to the limit, L over 229, L over 250, so just 10% over. So now it might be worthwhile checking the Canadian standards, but you can sort of get an idea of how easy it is to go back and forth between the model and the results just to get a design that's working. So I'm gonna go ahead and select the Canadian standard 086. And launching that module is going to import all of my material properties, all of the loads, all my section properties directly and into the module, and pretty much ready to run instantly. So I can just hit run. So I can say it is very close to failing. It's only 5%. So very close to passing. It's only 5% over the governing, the 100% utility. And one thing to really keep an eye out is just these unbraced lengths. So in real life, this might have some more restraints along the way. So by default, we do just select the full span of the beam because it's impossible for us to know if there's other connections to the beam. So there is obviously some restraint in the Y here. So we can see every 2 meters there is a support. So let's adjust some of those parameters to account for this. So we have support in the Y, an unbraced length, maximum unbraced length of 2000 millimeters. And you can kind of come to these info tips. They help a lot just to explain the different parameters and what they mean. So with that should be a bit more accurate. Now we can see that we are passing at 84% utilized. So that's a really good design. And we can review the report as well. So this would have been quite useful to do at the first step where we saw there was a failure, and we can come here and find out why it was failing. And if I went back, you would see that utility here was 105%. So I can see it's because of the strong axis, so just a bit too much bending moment, and it wasn't accounting for that L over Y. So you can even self-diagnose or look through the report and find weaknesses in the design and go back and optimize to make sure that you start passing the different design checks. But yeah, the transparent reporting makes that a lot easier, just so you can go back and forth, you can review the calculations and just make sure that it's an accurate depiction of what is happening in real life. So from there I can export the PDF to the design, or run a summary report as well, which is just a bit simpler. But that's pretty much it. That's all that goes into designing a timber element in SkyCiv Beam and using the design modules, the integrated design modules. Like I said, it's the same for NDS, AS1720 or Eurocode. So if you are designing a timber element in any of those standards, you can use the same process that we've showed you here today. So yeah, we look forward to having you on the platform, and if you have any questions, feel free to hit us up on the live support. Thanks a lot.